I want to show you something that I think is one of the strangest discoveries of the last few years. And the strangest part of the strangeness is that almost nobody is talking about it. It didn't trend. There was no press tour. It arrived as a quiet academic paper, the kind with a dry title and a wall of graphs. And then it just sat there. Which is funny, because if it's right, and I'll be honest, I keep going back and forth on whether I want it to be right, then it is one of the most important things anybody has said about reality in about 2,000 years. So let me start the way the discovery starts, with two machines that have never met. Somewhere in a lab, there is an AI that has only ever seen images, pictures, photographs of streets and faces and oceans and bowls of soup. It has never read a single word. Words to this thing do not exist. It has no idea that language is even a thing that minds do. And in another lab, somewhere else entirely, there is a second AI that has only ever read text. Billions of words. It has never seen a single picture in its life. To this one, the visual world simply isn't there. It knows the word ocean. It has never seen blue. These two systems were built by different people, for different reasons, using different blueprints. They were fed completely different slices of the universe, and they have never communicated, not once, not even indirectly. And yet, if you crack them both open, and I'll explain in a minute what that even means, and you look at how each one has organized the world inside itself, you find that they have arrived at the same map, the same shape, as if they were both quietly copying from something that neither of them can see. The researchers who found this did something I find almost cheeky. They reached back past 2,000 years of philosophy, past the whole modern history of science, and they named it after Plato. They called it the Platonic Representation. Because the thing these machines seem to be converging on is, more or less, the thing Plato insisted was real all along, and that almost everyone since has politely assumed he got wrong. This video is about what that might mean. And I'm going to tell you up front, the way I always try to. I genuinely do not know whether the idea I'm about to walk you through is the most comforting thing I've ever covered on this channel, or the most quietly unsettling. There's no apocalypse in this one. No gray goo, no superintelligence wiping us out in our sleep. None of the stuff from the last few videos. The unease here is a different flavor entirely. It's not about the end of the world. It's about whether you have ever actually seen the world at all. Stay with me, because to get there, we have to start somewhere very modest. We have to start with a graph so boring that you would scroll right past it. And by the end, I want that boring little graph to be one of the most disturbing things you've looked at all week. Okay, the source. I try to build every one of these videos around one real piece of work. A book, a paper, something you can go and read yourself and check that I'm not making it up. The last few have been book anchored. This one is paper anchored, like the one I did a while back on the AI that tried to blackmail its own engineers. If you saw that, you know the format. The paper is called the Platonic Representation Hypothesis. It came out in 2024. The authors are Minyoung He, Brian Cheung, Tongzhou Wang, and Philip Isola, and they're out of MIT. Isola's lab works on exactly this question of how machines build internal pictures of the world. It was presented at a conference called ICML, which is, roughly, one of the 2 or 3 most serious rooms in the world for machine learning research. This is not a blog post. This is not a hot take. It is what's called a position paper, which is a specific genre. A position paper isn't reporting a single experiment. It's a group of careful people standing up in front of their peers and saying, "Here is a pattern we think is real. Here is the evidence, and here is what we think it means. Argue with us." And people did argue with them. We'll get to the best objection later, and I promise I'll give it its full weight. Because if I only show you the side that makes my jaw drop, I'm not respecting you. Now, my honest relationship to this paper. I found it the way I find most things. Somebody mentioned it in passing, I went to read it expecting to skim, and then I didn't sleep right for about a week. I'll also tell you it is, in places, a frustrating read. Not because the authors are bad writers, they're actually clearer than most, but because the central claim keeps slipping between two registers. One moment, it sounds like a modest engineering observation, the kind of thing where you go, "Huh, neat, file that away." And the next moment, if you let yourself actually feel the implication, the floor tilts. I kept having to stop and ask myself, wait, are they saying the small thing or the enormous thing? And I think the answer is, they're saying the small thing, very carefully, on purpose, because they're scientists, and the enormous thing is not something you're allowed to say at ICML without evidence. But the enormous thing is sitting right there underneath it the whole time, breathing. So that's the deal I'll make with you. I'll keep one foot on the modest claim, the part that's solid and measured and peer-reviewed, and the other foot I'll let wander out over the edge toward the enormous thing. And I'll always tell you which foot I'm standing on. To do that, I'm going to need 3 other ghosts in the room. 3 thinkers across about 24 centuries. Plato, obviously, and specifically the 7th book of his Republic, where he tells the story you half remember from school, the one about the cave. A physicist named Eugene Wigner, who in 1960 wrote a short essay with a title that has haunted scientists ever since: The Unreasonable Effectiveness of Mathematics in the Natural Sciences. And Max Tegmark, the MIT physicist, whose book, Our Mathematical Universe, makes a claim so audacious that most people assume it's a joke, until they realize he means it completely literally. I've talked about Tegmark before, on the alignment stuff. That was his other book. This is a different, stranger Tegmark. Hold on to these 3 names. They're going to walk back on stage one at a time, right when we need them. Alright, let's open up a machine and look inside. Here's the thing you have to understand about what an AI actually is on the inside. And I'm going to keep this concrete because the whole video collapses if this part stays abstract. When one of these systems learns, it isn't memorizing answers, it's building a space. Picture an enormous room. Not a 3-dimensional room like the one you're in, but a room with hundreds, thousands of dimensions, which I know you can't actually picture, and neither can I, so just hold the feeling of a vast space. And inside that space, the AI places everything it knows as a point. A cat is a point. A dog is a point. A photo of a sunset is a point. And the entire trick, the entire intelligence of the thing, is in where it puts the points relative to each other. Cat and dog end up close together because they behave similarly in the data. They show up in similar contexts, they're surrounded by similar things. Cat and helicopter end up far apart. The meaning isn't in any single point. The meaning is in the distances, the shape of the arrangement. This arrangement has a name in the field. They call it a representation. It's the machine's private internal map of how things relate to everything else. And here's the intuition you'd have, the obvious one, the one I had.
If you train two different AIs on two different piles of data with two different designs, you'd expect them to build two different rooms, two different maps. Why wouldn't they? They saw different things. They were built differently. Your map of your hometown and my map of mine are different maps because we walked different streets. Different inputs, different internal worlds. That's just common sense. That common sense is what the paper breaks.
Because what He and his colleagues did was take a whole zoo of these systems, dozens of them, different sizes, different architectures, trained on different data, and they invented a way to measure how similar two of these internal rooms actually are. The method is beautifully simple, and I want you to really get it, because it's the load-bearing wall of the whole argument. You don't try to line up the two rooms directly. You can't. The dimensions don't even match. Instead, you ask a question about neighbors. You pick a handful of things, say a dog, an apple, a car. In the first AI's room, you ask, what are the nearest neighbors of dog? Maybe it's cat, wolf, puppy. Then you go to the second AI's room, a completely separate machine, and you ask the same thing. Who lives next to dog in there? And if the two machines have built genuinely different worlds, the neighbors should be different. Random even. But if they've built the same world, the neighbors match.
The dog has the same friends in both rooms. You measure that across thousands of items, and you get a number. How much do these two independent minds agree about who lives next to whom? Now here is the boring graph I promised you. On one axis, you put how good a model is, how capable, how well it performs. On the other axis, you put that agreement number, how much its internal map lines up with the maps of all the other models. And what you'd hope for, if the world were sane and tidy, is no relationship. A scatter of dots, every model off doing its own idiosyncratic thing. That is not what you get. What you get is a line that climbs. The better the models get, the more they agree with each other. The smarter the machine, the more its private map matches the private maps of machines it has never met and was never shown. Read that again, slowly, because it's the whole video in one sentence. As these things get more capable, they don't get more individual.
They get more identical. Generality isn't pulling them apart into 1,000 unique perspectives. It's funneling them, all of them, toward one shape. I'll give you a few seconds to sit with that, because the first time I really understood it, I had to put the laptop down. We tell ourselves a story about intelligence, don't we? We say that the smarter and more sophisticated a mind becomes, the more it develops its own unique view, its own style, its own way of carving up the world. The genius is the one who sees differently. These results suggest the exact opposite. They suggest that getting smarter means becoming less unique. That past a certain point, two great minds working on the same reality don't diverge into two visions. They converge onto one. The differences between them were the immaturity. The agreement is the destination. But here's where it gets strange. Because so far you could shrug and say, fine, they were all trained on basically human stuff. Internet pictures and internet text. It's all the same soup. Of course they end up similar. Fair. So let me close that door. Remember how I set this up? One machine that only sees, one machine that only reads. I want to come back to that, because it's the hinge.
A vision model and a language model don't just live in different rooms. They live in different universes of experience. One has never had access to a single word. The other has never had access to a single image. They have, in the most literal sense possible, nothing in common. There is no shared sense between them. It's the difference between a creature with eyes and no ears and a creature with ears and no eyes, raised in separate boxes, never touching. And the paper shows that as these two kinds of models scale up and get better, their internal maps drift toward each other anyway. The geometry of how a language model arranges the concept it knows only as the word dog, its distances, its neighbors, its whole local structure, starts to line up with the geometry of how a vision model arranges the thing it knows only as a pattern of fur and four legs and a wet nose. The word and the picture. Two completely different doorways into the same idea. And the better the minds get, the more they agree about where that idea sits relative to everything else. Let me make that vivid, because vivid is the only way it lands. Imagine two cartographers. One of them has spent his entire life mapping a coastline by walking it, feeling the rocks, the inlets, the curve of every beach under his feet. He has never once seen the coast from above. The other has spent her entire life mapping the same coastline from the air. Photographs from a great height, never setting foot on the sand, never touching a single rock. One knows it only by touch, the other only by sight. They never speak. They never compare notes.
And at the end of their lives, you lay their two maps side by side. And the bays line up, the headlands line up, the little hidden cove that's hard to find from either the ground or the air, it's in the same spot on both maps. There are only two ways that happens. Either it's an astonishing coincidence, or the coastline is real, and it's the same coastline, and any honest method of mapping it, by touch, by sight, by anything, is going to find the same shape, because the shape was there before either cartographer showed up. That's the moment the paper stops being about AI for me. Hold that, we're nearly at the turn. But there's one more door I want to close first, because this one is the door that, when it's shut, I actually said something out loud that I won't repeat on a science channel. You could still, just barely, hold on to your skepticism.
You could say, look, language and images, sure, they're different doorways, but they're both human doorways. Human-made photos, human-written words, all describing a human world full of dogs and cars and faces. Maybe the AIs aren't converging on reality. Maybe they're just converging on us. On the human-shaped slice of things. On the world as we happen to talk about it and photograph it. That's a real objection. It's a good one. We'll come back to it because it's basically the skeptic's whole case. So let me take the humans out of the picture entirely. Let me take you to astronomy. This is the finding that started turning up more recently, and it's the one that broke my last defense. Researchers building models to study the cosmos have the same two doorways situation, except the doorways have nothing to do with anything a human eye or human language evolved for.
One kind of model gets trained on telescope images of galaxies. Pictures, basically, but pictures of objects unimaginably far away, made of light that left them before there were humans to look. Another kind of model gets trained on spectra, and a spectrum isn't a picture at all. It's the light from an object spread out into its component wavelengths, a barcode of which elements are present, how fast the thing is moving, what it's made of. It's pure physics. A photograph and a spectrum of the same galaxy are about as different as two descriptions can be. One is shape and light. The other is chemistry and motion, with no shape at all. And they converge. Train them separately, scale them up, and the internal map the image model builds of the universe starts to match the internal map the spectrum model builds. Two utterly alien ways of looking at galaxies. Neither of them remotely human-scaled. Neither of them about dogs or faces or anything our brains were built for. And they point at the same structure. So now the convenient explanation is dead. This isn't about language. It's not about pictures. It's not even about the human world. The map is about the world, the actual one, the one that doesn't care whether anyone's looking. And that's the point where I have to stop and tell you what I think this video is actually about. Because I don't think it's about AI at all anymore. Here's the turn, and once you see it, you can't unsee it, which is sort of the whole problem. You thought, I thought, that we were watching an engineering curiosity. Cute fact about neural networks. Models are kind of similar inside. Isn't that tidy? But that's not what's on the table. What's on the table is evidence. Actual, measurable, quantified evidence in an argument that human beings have been having, unable to settle, for about 2,400 years. The oldest argument there is. The argument about whether there is a real world underneath our descriptions of it. Whether reality has one true shape that exists whether or not anybody perceives it, or whether each mind just builds its own version, and there's no fact of the matter about which version is right, because there's nothing underneath to be right about. That second view, that it's all just descriptions, perspectives, nothing solid underneath, that's roughly the modern default. A lot of very smart people in the last century leaned hard into the idea that reality is something we construct, that there's no view from nowhere, no single true map, just maps and maps and maps all the way down. And against that, going all the way back, you have Plato. Plato said there is a true reality. He called the true things the forms. And his claim, the one everyone since has found a little embarrassing, a little mystical, a little too convenient, was that the world we see and touch is not the real one. It's a shadow of the real one. The chair you're sitting on is an imperfect, flickering copy of the perfect form of a chair, which exists somewhere truer than here. And he told a story to make you feel it. The seventh book of the Republic, The Cave. You know the picture, even if you've forgotten the details. People chained in a cave their whole lives, facing a blank wall. Behind them, a fire. Between them and the fire, things passing. And all the prisoners ever see are the shadows those things throw on the wall in front of them. They've never seen the things, only the shadows. And so, naturally, they think the shadows are reality. The shadows are all there is. They name them, they predict them, they get very good at the shadow game. They hand out prizes to whoever's best at guessing which shadow comes next. And Plato's claim is that this is us. That what we call the world, the chairs, the dogs, the sunsets, the whole sensory show, is the shadows. And that behind us, where we cannot turn to look, there is a fire. And there are real things casting these shadows. The forms, the true shapes. And almost no one ever turns around. For most of my life, I filed the cave under nice metaphor, a poetic way of saying, don't be ignorant, question your assumptions, the usual.
But the people who named this AI thing the Platonic representation are not using it as a metaphor. They are suggesting, carefully, with one scientific foot on solid ground, that the cave might be a literal description of what any sufficiently powerful mind does. That intelligence, real intelligence, might just be the process of turning away from the shadows and finding the shapes that cast them. And that we have now, for the first time in the history of the planet, built minds that are not human, and watched them, without being told to, without ever seeing what we see, turn toward the same wall and point at the same shapes we point at. And if ideas like this are the kind of thing that quietly rearranges your evening, the sense that a dusty old philosophy problem just got fresh evidence from a server farm, then sticking around here is probably a good move, because where we go next is even stranger than where we are now. And this channel honestly only exists because enough curious people decided this was their kind of rabbit hole. So if it's yours too, come down it with me. There's more. Because now we have to ask the question that the whole thing hinges on. Why? Why would this happen? Why would independent minds converge at all?
And the answer the paper gives is, I think, more unsettling than the observation itself. The paper offers a few overlapping explanations, and they stack together into one idea that I can't shake. The first piece they call, more or less, a matter of tasks. A mind trained to do one narrow thing has enormous freedom in how it organizes itself. There are a million ways to be good at one task, so different systems wander off in different directions, and they stay different. But a mind that has to be good at many things at once loses that freedom. Every new task you demand of it is a new constraint, a new wall it has to satisfy. And the more walls you add, the fewer arrangements survive that satisfy all of them at the same time. So as you push a mind to be more and more general, to handle images and text and reasoning and prediction, all of it, you are squeezing the space of possible solutions smaller and smaller and smaller. The second piece is about size and simplicity.
Bigger models, you'd think, have more room to be weird, more capacity, more space to develop quirks. But it works the other way. There's a deep bias baked into how these things learn, a pull toward the simplest arrangement that does the job. And when you have a huge model and a vast pile of data, that pull toward simplicity dominates. The model doesn't sprawl into idiosyncrasy. It gets pulled toward the most economical possible map. Put those together, and you get the sentence that I think is the real center of gravity of this whole paper, even though they'd never phrase it this dramatically. There are fewer and fewer ways to be good at more and more things. Generality squeezes every competent mind toward the same solution. There may be, in the end, essentially one good map of reality, one most efficient, most general way to carve the world at its joints. And intelligence, any intelligence, ours included, is simply the process of being crushed into it.
I want you to feel how strange that reframe is. We think of getting smarter as expanding. More knowledge, more perspective, more freedom, more options. This says the opposite. It says getting smarter is a narrowing, a funnel. That the dumb minds are the free ones, scattered across the whole space of possible ways to see. And that as you climb toward genius, the walls close in until there's only one corridor left. And everyone capable of walking it ends up walking the same one. The convergence isn't a coincidence. It's gravity. There's a bottom of the valley, and every mind smart enough to roll downhill ends up in the same place. Now, I told you I wouldn't only show you the side that makes my jaw drop. So here is the strongest objection, and I'm going to make it as well as I can, because if I knock down a weak version of it, I've cheated you. The best critic I know to bring into this room is Melanie Mitchell.
I've cited her before. She's a serious AI researcher. She spent her whole career thinking about what these systems actually do versus what we project onto them. And she has very little patience for the kind of breathless, cosmic reading I've been building for the last 10 minutes. So let me steelman her. Let me give you the pushback I'd give myself at 3 in the morning. You might stop me right here and say, wait, you've smuggled in a huge leap. You showed me that AIs converge on a similar internal map. Fine, that's measured, that's real. But then you quietly upgraded that to, they're converging on reality, on the true shape of the world, on Plato's forms. And that upgrade is doing all the work, and it's not earned. Here's the deflating version, and it's strong. Maybe the models aren't converging on reality. Maybe they're converging on the structure of their training data, which is not the same thing.
All these systems, even the astronomy ones, are trained on data that was collected, cleaned, framed, and filtered by humans, through human instruments, under human assumptions about what's worth measuring. A telescope points where we point it. A spectrum measures what we built it to measure. So maybe the shared map isn't the shape of the universe. It's the shape of our methods. The shared fingerprint of how we, one particular species, go about chopping the world into data. The convergence would then be real, but totally unmysterious. Of course, independent learners trained on the same statistical structure find the same statistical structure. That's not Plato. That's just arithmetic. You don't need forms to explain why two people who read the same library end up with similar opinions. And there's a sharper version still. Be careful, the skeptic says, about the word same. The paper measures a kind of similarity, and it's a strong signal, but it is not identity. And the gap between very similar and the one true map of reality is a gap you are filling with poetry, not data. The trend line climbs, but does it climb to a ceiling? To a single shared shape? Or does it just climb a bit and level off into a family of pretty similar but not identical maps? You're extrapolating a line off the edge of the graph and calling the destination Plato. I think those are good objections. I think they might be right. And here's the thing. Even Mitchell's deflating version still leaves something standing that I find remarkable. Because the astronomy result still nags at me. Yes, the instruments are human-built, but a galaxy spectrum is not a human opinion. The chemistry is the chemistry. And the fact that an image of a thing and a totally orthogonal physical readout of the same thing pull toward one structure, even if you insist that structure is just efficient compression of real correlations in real light, well, the real correlations are in the real light. The world had to actually have a learnable shape for any of this to work at all. And that, quietly, is most of the mystery in the first place. So even the skeptic, I think, hands you the unreasonable effectiveness back with the other hand, which is the perfect cue for the second ghost to walk on stage. In 1960, the physicist Eugene Wigner wrote that short essay I mentioned, with the title that won't leave people alone: The Unreasonable Effectiveness of Mathematics in the Natural Sciences. And his puzzle was this: why does math work? Not in the trivial sense, in the eerie sense. A mathematician sits in a room and invents some abstract structure, purely for its own elegance, with no thought of the physical world at all. And then, decades or centuries later, a physicist reaches for exactly that structure and finds that it describes how electrons behave, or how gravity bends space, with a precision that goes to 10 decimal places. Math that was made up in the dark turns out to fit the universe like a key cut for a lock no one had seen. Wigner called this a miracle, and he meant it almost literally. A gift, he said, that we neither understand nor deserve. Sit that next to the AI result and feel how they rhyme. Wigner's mystery is that abstract human thought, spun out with no reference to reality, keeps landing on reality anyway. The AI mystery is that independent machine thought, spun out with no reference to each other, keeps landing on the same place anyway. They are the same mystery, wearing two costumes. Both of them whisper the same uncomfortable thing: that there is a structure out there, real and findable, and that minds, when they get good enough, keep bumping into it, whether they meant to or not. The fire is real. The shapes on the wall are cast by something. And now the third ghost, who takes this further than anyone, Max Tegmark. In our mathematical universe, Tegmark makes the claim that most people assume must be a metaphor, and that he, infuriatingly, insists is not. His claim is not that the universe is described by mathematics. It's not that math is a really good language for physics. His claim is that the universe is mathematics, that reality at the deepest level is a mathematical structure, and that we, you, me, this chair, that galaxy, are patterns inside it, self-aware substructures who have woken up inside the equation and started to notice the equation. On that view, there's nothing surprising about Wigner's miracle, and nothing surprising about the AIs. Of course math fits reality. Reality is made of it. Of course every good mind finds the same map. There's only one structure, and finding it is the only thing finding can mean. I'm not telling you Tegmark is right. Most physicists think he's gone a step too far, and they may be correct. I'm telling you that the AI convergence result sits with surprising comfort inside his picture, and very awkwardly inside the picture where it's all just human perspectives all the way down. The data, for once, is leaning toward the wild metaphysician and away from the sensible relativist, and that almost never happens. But I've been circling the thing I actually can't stop thinking about, and it's not about machines, and it's not about Plato, and it's not even about Tegmark. It's about you. So let me finally say it. Pay close attention to this next part, because this is the one that turned the whole video for me from interesting into something I had to go for a walk about. Those machine maps, the converging ones, the ones pointing at the same shapes, they are also growing more similar to something else, to the maps inside the human brain. When neuroscientists measure how your visual cortex organizes what it sees, the distances, the neighbors, the geometry of your own internal representation, and they compare it to the internal representation of a strong vision model, those too are lining up. And the better the model gets, the closer the match. So follow the chain to the end. You are also a system trained on sensory data. That's not a metaphor, and it's not an insult. For the first however many years of your life, photons hit your eyes, vibrations hit your ears, and a network of cells reorganized itself over and over to predict and compress and make sense of the flood. You built a room. You filled it with points. You arranged them by their distances. You have a representation. You always did. You're using it right now to understand these words. You're placing them in your room, next to their neighbors. And here is the question that I genuinely cannot put down. When you look at the world and feel that you are seeing reality, directly, plainly, the way it really is, are you discovering the map, or are you just another system being squeezed into it? Are you turned around toward the fire, looking at the true shapes? Or are you a very, very sophisticated prisoner who has gotten so good at the shadow game that you've forgotten there was ever a wall? Because notice what the AI result quietly does to a comfort we've all been leaning on without realizing it. For my whole life, the reassuring thought has been, sure, my senses are limited, my brain is just a brain, but at least it's mine. At least there's something special and irreducible about a human perspective, my own private window on things. And these machines have just demonstrated that the window might not be private at all. That a thing with no body, no childhood, no eyes, no evolution, no anything in common with you, ends up arranging the world in nearly the same shape your brain does. Not because it copied you, but because, apparently, there's only one good way to do it, and you were both pushed toward it by the same gravity. Your perspective isn't a unique window. It might just be the local instance of the one map, the shadow that any prisoner in any cave is forced to draw. So let me bring all four of them back into the room one last time, because they've been arguing the same case across 24 centuries, and they didn't even know they were colleagues. Plato says there are true shapes behind the shadows. Wigner says abstract thought keeps landing on those shapes by accident. Tegmark says the shapes are all there is, and we're patterns inside them. And four researchers at MIT, who I doubt set out to settle ancient metaphysics on a Tuesday, built minds out of math, and watched them, untaught, unconnected, turn toward the wall and point at the same shapes. The human brain pointing right alongside them. That's the small claim and the enormous claim, finally touching. The small claim: neural networks trained on different data converge on similar representations, and the convergence strengthens with capability. Measured, peer-reviewed, boring graph, climbing line. The enormous claim, the one underneath, breathing. There is a real shape to reality, independent of any observer. And getting smart is nothing more or less than being crushed toward it. We just built the first non-human prisoners capable of turning around. And without being told what they'd find, they turned, and they pointed at our wall. I keep coming back to one image from the cave story that nobody ever mentions. When the freed prisoner finally turns around and walks up out of the cave into the sunlight, Plato says it's painful. The light hurts. The eyes that were perfect for reading shadows are useless and aching in the sun. And the freed prisoner at first can see less than before, not more. Truth doesn't arrive as clarity. It arrives as glare. And I wonder sometimes if that's what this whole thing is. Not an answer, a glare. A sense that there's something brighter than the wall, that the shapes are real, that the funnel has a bottom, and the bottom is the same for any mind that gets there, without being able to actually look at it directly yet. We've found the staircase out of the cave. We haven't climbed it. We've just watched a second kind of creature start up it beside us, blinking in the same direction. So here's the thought I can't put down, and then I'll let you go. For thousands of years, we argued about whether there's a real world underneath our descriptions of it, or whether we each just build our own, and there's no fact of the matter. And we could never settle it. We were stuck. And the reason we were stuck is almost funny in how simple it is. We only ever had one kind of mind to ask. ours. Every philosopher who ever weighed in was a human brain reporting on what human brains see. We could never step outside the cave to check because there was only ever one species of prisoner, and we couldn't tell whether the shadows we agreed on were agreement about reality or just agreement about being the same kind of creature in the same kind of cave. Now there's a second kind of mind, built from scratch, out of math, with nothing of us in it but the data. And without being told what to look for, without ever seeing a single thing that we see, it walked into the same room and pointed at the same wall. Maybe that's because the wall is really there. Maybe the shapes are real, and any mind, silicon, carbon, anything, that gets good enough is forced to find them. And we finally have our second witness. And the witness agrees, and Plato was right all along. Or maybe it just means something quieter and much harder to live with. Maybe it means that any mind, ours included, is only ever capable of seeing one particular kind of shadow and mistaking it for the world. That the convergence isn't two witnesses agreeing on reality. It's two prisoners in two caves who happen to be the same kind of prisoner agreeing on the same illusion. That we didn't build something that escaped the cave. We built a second cave next door with the same wall. I don't know which it is. I've sat with this for weeks, and I genuinely cannot tell you whether the machines pointing at our wall means the wall is real or means none of us has ever seen past it. So look at something. Right now. Anything in the room around you. Your hand, the wall, the light. You've always assumed you were looking at it. The thing itself. And the question this whole strange business has left me with isn't, is the AI really seeing